To probably the most anticipated research talk at Microsoft Research in 2003, Murray Sargent's talk on actually doing high-quality math in the Office suite. So without any further ado, Murray.
Thanks, Jim. Well, this is a very exciting moment for me, anyhow, because I guess some of you know this. I came up to Microsoft in '92, and one of the things I really wanted to do, and one of the reasons I gave to the University of Arizona, was I want to get high-quality math into Microsoft Office. And you know, in the research division, you kind of do what you want to do, but when you're in a development division, you have to kind of do what other people want you to do. So the trick is to be patient, and actually the patience is paid off, as you're going to see in this talk, in more ways than one. It couldn't have been done in '92, so that's one of the major features. Part of the reason that it couldn't be done was the first item I have here. About 8 math infrastructures inside and outside of Microsoft have come to be. A couple of them were there already in '92 or earlier, but several of them only came about in the last 5 years or so. Or, in fact, a couple aren't even quite there yet. But that's part of the project. So I'll tell you what those 8 infrastructures are. And I'll show you a new math edit display environment, which I believe is an improvement on earlier environments. And the hope is to provide an infrastructure for editing programs to support build-up formulas in general, not just in the main applications. But the emphasis is on Word 12, OneNote 2.0, Rich Edit, which is the editing engine that a lot of programs use, and PowerPoint 12, which will be using Rich Edit as its text engine, so it automatically inherits math capability. And we can probably retrofit Internet Explorer as well. One of the cool things about this infrastructure is that we do use MathML as one of the formats for persisting equations, and as such we're interoperable with all the popular math software, including Mathematica, MathCAD, MATLAB, and so on. So,
is tech on that list?
Tech plays a major role, as you're going to see. I think we are doing better in tech in just about every way you can imagine, so I'll show you that. MathML does have tech converters, so you can go from MathML to tech and back. There are a number of programs to do that. This is a big effort, and it would be impossible to do it solo. Fortunately, I've got the help of some incredibly capable people. So Eliezer Cohen and his group, Victor Kozarev and Andre Barago, are working on this. Actually, the whole line services and PTS group is interested in the math stuff, and so we have lots of conversations, and it helps to improve it. We have a Word PM, Jennifer back there, is one of her jobs is to spec out what goes into Word, and Word is sort of the leader, so once it's in Word, then we can put it in other things. We have a new font, which is being developed by Monotype, and Mike Duggan back there, and Geraldine Wade and Greg Hitchcock also back there are involved with the new font. The new font will have the full Unicode math character set, which is the largest math character set in existence. We have OpenType typography, which is very handy for doing some special kinds of kerning. Among the people, well, Eliezer developed the OpenType spec, and Sergey Malkin back there is working on OpenType, so we can really tweak the font to really do math in a beautiful way. And then just in general, there's developers and test and program managers of a variety of areas: Rich Edit, Line Services, Page Table Services, Word, OneNote, Office Art. And then Microsoft Research is getting into this too, in a very significant way. It's a collaboration between you guys and Microsoft Research in Asia in getting in handwriting. input, which is one hell of a fine kind of input. That's being developed. Outside the company, there's the whole Unicode Technical Committee and the MathML user group, and in particular, I'd like to mention Barbara Beaton of American Mathematical Society and Asmus Freitag as being people that have helped an awful lot in the math effort in general. Okay, what are they? What are the 8 incredible math infrastructures that, well, one of them you've seen for a long time. LaTeX, or TeX and its various kinds, have been around since the mid-'80s. It's very important work. There's been work, there's an important effort in Unix called EQNTROF, which is arguably competitive with TeX and LaTeX. But it missed the boat on a couple of things. One, it just stayed with Unix. It didn't try to get on any other platforms, and so it just wasn't popular. It just didn't get adopted by other groups. And another is that Don Knuth did an incredible job documenting TeX. So we've been literally going and picking TeX apart piece by piece and stealing any good idea in there, and also noting where they're just simply shortcomings and where you can do better. TeX has a huge influence on this project. Unicode 4.0, that's the latest Unicode. It's the big book if you've seen it. It has about 2,000 math symbols. Now, this doesn't include anything dotted or tilted or careted or anything like that. These are basic math symbols. They are a union of all the math symbols that math publishers around the world wanted. They include AMS TeX, ordinary Rev TeX, LaTeX. All those guys are in there, plus a lot of others. Some of them are really, really weird, and so I'll give you a slide showing some of the weirdness that got in there. As a theoretical physicist, a lot of these characters I've never seen. They are bizarre. MathML 2.0 is out. I think it may still be a draft, but I think we've all voted to accept it. It's Math K through 12 and beyond. It can do more than that. It's the first W3C sanctioned XML. It preceded all the other XMLs, and it's got some good features and it's got some bad features. But basically, it's a standard that's well defined, well documented. It's an excellent manual that's out there on the W3C website if you want to go out and check it out. So it's very valuable. Also, the guys on there, several of them, like David Carlisle, are TeX experts and have been in the TUG groups for a long time. So they know what goes on with TeX. So there's good representation there, and MathML is set up so that it can be interoperable in nice ways. OpenType, we will do the special math tables to allow special kinds of kerning. I'll show an example of that. And there's a lot of other stuff that we can do with OpenType. So it's a much more powerful font technology than Knuth developed. Although for the time when Knuth did it, it was extraordinary. But let's face it, we can do better now. Now, some of you may know about line services. This is a line layout program that's used by all major text engines at Microsoft. Name any one, it uses it. So this is an infrastructure which is very powerful, and it was built from the ground up to handle mathematical formulae. That wasn't how it was sold to management, but the fact is, it's a beautiful recursive measuring machine. There's going to be a new handler by Eliezer and Co. This as a result of tremendous searches through mathematical typography literature. So then there's Rich Edit 6.0. It's a project I've worked on for 8 years. Earlier versions had lower numbers. And I developed a math handler for line services that we've been using for just developing our ideas. It will be thrown away when the new one comes into being. And then the final piece is just the Microsoft Office environment. There's just a huge amount of power in terms of editing documents. It's available there, not only spell checking or grammar checking and things like that, but also things like autocorrect, which can be very nicely extended for mathematical purposes to do nifty things I will show you. So probably I don't need to say much of anything about LaTeX here. It's a very well-known system. very widely used. It has simple ASCII keyboard entry. That's because it wanted to run on everything out there. It's beautifully documented. It's stable. I guess Knuth maybe just did come out with a new version with a couple of bug fixes. But basically, it's been an extraordinarily stable product. And if you've ever looked at the code, you'll just won't understand how it ever happened to be so stable, because it's the weirdest looking code. It's this graphical stuff, no hierarchical kinds of things that we like to think are good programming practice, but beautifully documented. Okay, on the downside, two downsides to TeX. Complex formulas are hard to manipulate. If you can think sort of blindly, you can sort of do it, but it's hard to manipulate. It's much easier to manipulate something that's a built-up formula that looks like it does in a book. And then one of the things that people rave about with the TeX family are the macros, because you can tailor it to suit your purposes. And it makes interchange almost impossible. So the macros are in a sense a bane of the TeX world, as well as being a blessing. And one of the nice things about MathML is that it doesn't have that feature. There aren't any macros in MathML. It's well defined. If you see it, you know exactly what it means. You don't have to go look some other place to figure it out. A downside of that, quite frankly, is that MathML is amazingly verbose. I mean, I think TeX is verbose. And so when I first saw MathML, I must say I lost it. I joined the MathML committee, and I actually lost it. I almost went berserk in the meeting. I said, guys, this is ridiculous. And I gave them this long list of things that, look, Unicode has all these gorgeous math properties for all these different characters. We should have tags which say that inside these tags, the properties of these characters are the default Unicode properties for those math characters. And I couldn't get them to put it in. It would have given a compression of like 10 to 1 maybe, because now you declare, well, you'll see. You declare everything in sight. But, okay, it works great, and it's interchangeable, and math formulas are not the large parts of most documents anyhow. Things like bitmaps are bigger. So let's go on to the next one, Unicode 4.0. Unicode 4.0 has about 2,000 characters. There were about 340 characters before we had the STIX push. STIX is Scientific and Technical Interchange Project, which was this group of consortium of math publishers and math interested groups that put together and said, we need all these characters. So then we added a slew of those. We added 1,016 math alphanumeric characters. And this caused a huge howl where people said, no, you shouldn't do that. This is formatting. You're adding math italic and math bold italic, and people got all upset about that. Well, they're all wrong. It's a great idea, and it works really well. And I'll show you some examples of why having the characters actually as part of Unicode are great. In particular, you don't lose all sense of a math equation if you just copy it in Unicode. And I think that covers that. Here are some of the weird characters. Like, do you need those characters? I don't know. Maybe you do. Some people like them, at least. This is just a small number. If you want to see all of these characters, you can go out to the Unicode site, www.unicode.org, charts. And Unicode 4.0 is completely out there, so you can see all the characters. Oh, yeah, there are some pre-composed things. That's true. That's true. Yeah, there are some pre-composed things. But in general, the way you like to handle tildes is with a combining mark. And MathML prefers to do it that way also. Okay, so the alphanumeric characters, there are digits, there are Latin letters, there are Greek letters, plus a bunch of variants, like two kinds of epsilons, just as in TeX. And phi and theta and kappa and rho, they all have variants. And generally, it's only unaccented forms. But that's a good point. I should fix that up. So no, thank you.
So you also have, in addition to the Nachlass, a square?
The square guy.
Tail version.
Yeah, that's in there. Oh yeah. if you can come up with a character that actually has appeared in print
I mean, you
that we
said-
don't have.
You said Greek plus Napla, so it seems that somehow you think of Napla as part of the Greek alphabet.
Yeah, it was a convenient place to stick it.
But the square is not there.
The square is not there, but we have a lot of squares in Unicode. So, a different size squares and so on. Okay, so here's a reason why we wanted to have the math typed character sets like math italic, which is not the same as italic, by the way. It has different spacing. But we wanted it for a couple of reasons. One is a basic Unicode rule that plain text must contain enough information to permit text to be read legibly and nothing more. Well, as I'll show you on the next slide, if you take a particular formula that I used to use a lot and cast it into plain text, you'll totally change the meaning of the equation. Totally change the meaning. So you will fail to satisfy this rule. This rule played a major role in getting this set of characters into the text. Another reason is plain text searches are the most standard way to search for text. And in the plain text search, you don't want to hit an italic H if you're interested in a script H, because they're just different variables. They aren't the same variable. It's a totally different meaning. A side effect of this is that having these characters reduces markup verbosity, but I'm not pushing that particularly. There's another cool thing.
You want to search for an H and you don't know whether it's italic or not.
Well, you can have a little checkbox. Usually search dialog boxes come up with a whole slew of little checkboxes, and so you could say ignore math styling and then match all H's in Unicode. So yeah, I mean you could do that, and that's a fairly common practice. The most typical being ignore the difference between upper and lower case. So another thing that I didn't put on this slide, but probably should have, is that by having these all in one font, we can use open type tables to do fabulous kerning that's not possible otherwise. Or at least it's not possible with our current technology. I guess anything's possible. So here's the Hamiltonian formula that I used a lot over the years. And you can see that if I cast that into a monostyle form for plain text, I would get an integral equation. The integral equation has those characters in it. It is Unicode, and Unicode has those characters. But you end up turning this Hamiltonian formula for the energy into an integral equation where H is determined by an integral over the volume of H squared and things. So you've totally changed the meaning. It's hopeless. Okay, so now you start to realize that we can do a lot with Unicode plain text. And we can do a lot with math with plain text. But you're not going to be able to do everything with plain text, and so we're going to need some more goodies. Plain text can represent BiDi. There's some strange things that get into handling embedded codes. You have lots of semantics in the Unicode manual, which differs, by the way, from ISO 10646, which doesn't have nearly as many semantics ascribed to characters, even though it does have a one-to-one correspondence of all the characters in Unicode. So at any rate, we're using this plain text, or at least a linear format, for formula entry and for searching. It works pretty well. In general, Unicode's not supposed to represent everything. And one of the things that we've been working on is how to represent glyph variants. I don't know if you've seen the Poetica font, but the Poetica font has 58 ampersands in it. It's a lot of different ampersands. How do you represent them? You could, in principle, represent them by rich text formatting of some kind, or tags. We don't really have an answer for that, but we are confronted with this problem big time, because in the East Asian world, they want to add lots more characters that are just slight differences, little artistic variations on the same character. And so you start to say, well, do we really want to have all of those variations as separate code points in Unicode? I mean, we could actually get into numbers like, another 128,000 characters. Unicode currently has about 96,000 characters. And so maybe using variant tags would be a good idea. So TeX is actually a plain text encoding, but it's a markup language. Okay, Tim Berners-Lee came out and said, this is his wish, MathML will make the web even better for educational, scientific, and technical materials. It also has the potential to make mathematics accessible to those with visual disabilities. He said this quite a while ago. I think he said it back in the early 90s. It will allow mathematical content to be reused and exchanged with technical computing systems for further manipulation. Well, it's all come true. Here's a history of MathML. MathML 1.0 was released in 98, and it's a low-level format, and I'll give you some examples of it. It certainly facilitates the use and reuse of scientific content on the web. And basically, MathML 2.0 is out, so if you want it, you can go get it. So here's an example. This is a famous equation. I used to use it as a password. It's a good password, by the way. Anyway, it mixes things up, and don't use it if you're going to go to a Spanish-speaking country, though, because you can't get the caret. It's very hard to get the caret on Spanish keyboards. So equals MC squared can show up exactly that way in Unicode. Unicode plain text can have that formula as you see it, without any markup at all. Nevertheless, if you're going to go with MathML, which you are, you're going to represent it as a sequence of embedded tags here. You have an mrow, which talks about the whole thing. Then you have the E has got to be an identifier, so just you can't assume that the E is going to be an identifier. You have to say so. The equal sign is tagged as an operator, so it will be an operator and not misinterpreted as an identifier. And then this actually has some nice structure. This is the presentation markup. Has some nice structure, kind of giving you a feeling for what's going on by putting an optional, in this case, but recommended mrow around the right-hand side of the equal sign. And so then inside that, your M has to be declared to be an identifier. And then there's an implicit invisible times between that and the C. And then you have a superscript expression which has a base consisting of C and an exponent consisting of a number, MN. It's a number tag. And so that's what it looks like. Now MathML has two tag sets. One is aimed at presentation, which is sort of similar to TeX. TeX is a presentation language. And another is the content form. And the content form is set up to really say what the thing means semantically. And for many kinds of mathematical expressions, you can go between the two without any loss. But sometimes the content form doesn't tell you how it should be displayed, and vice versa. The presentation form may not really tell you what the content is. Like a superscript is probably raising something to a power, but it could also be an index. And if you do it with the content markup, you will know what it means, whereas you may not know what it means in the presentation case. And it is...
Does it mean I can feed this formula into a spreadsheet and then I define M to be something and C to be something and this one not be?
That's part of the dream. Well, we want to get MathML into Excel, but there are other spreadsheets. I don't know of any spreadsheet right now that's accepting it, but you could certainly do it with Mathematica or MathCAD or Derive.
But you want to get it in Excel.
Obvious. No, it would be great to have it in Excel, and I'll comment on how we might be able to do that. Okay. So OpenType, you can make specialized math tables and position subscripts and superscripts horizontally better than TeX. One of the things that you do in TeX, if you want to really make it look good, is you end up adding lots of little thin spaces or negative thin spaces to kind of kern stuff in ways that TeX might not have figured out to kern. TeX is very good at spacing mathematical equations, but there are cases where you just want to tweak it. And one of the hopes is that the OpenType will allow us to reduce the need for tweaking tremendously. An example is this one here. And Victor Kozyrev said he showed this to his wife, and she didn't know what the difference was between the top line and the bottom line. But at any rate, this really makes a difference. Makes a big difference as far as I'm concerned, as far as Dave Hansen over there is concerned too, because we both have worked with perturbation energies over the years. Me perhaps more than he, because he cut out relatively early in his career to be seduced by computers. But at any rate, we have multi-mode lasers, and in multi-mode lasers you have some subscripts, and you have a script V. This script V doesn't have as big an overhang as the fonts that we were using, but it's still an overhang. And because the script V is actually part of the Unicode mathematical character set, we have the ability of saying, look, kern them. Now, we couldn't have done that if it hadn't been, at least we couldn't have done it with the standard techniques if we didn't have the script V as part of the standard character set. So, in other words, ordinarily you can't kern between different fonts. But in this case, they're all part of the same font, so then you can kern it. Okay, so the new math font is being designed by, I don't know if I can say this right, Jello Basma, and it's produced by Agfa Monotype, and it's containing, or will contain math-specific OpenType tables and the full Unicode math set. It's not the only full Unicode math set, by the way. Styx is also creating a new math font, which has full Unicode math set.
So I still don't really understand. What is OpenType? Can you give me
OpenType is an add-on to TrueType that allows you to have extra tables. And there's an OpenType library. They're real experts on OpenType in the room, by the way. So if I say anything wrong, chime in. You can have new tables that allow you to do marvelous things. They don't do it automatically. The information is there for you, and the program interpreting the tables is responsible for taking advantage of them or not.
It would have something like
Yeah, well, it does. I think regular TrueType tells you what the overhangs are as well, but this will gives you all kinds of cool things like the attachment points, where to put a caret, where to put a tilde, where's the best place on this glyph, things like that. So OpenType gives you very, very powerful font technology. Allows you to do things in a very beautiful typographic way. The new math font will become the default Word font for going into the future, and it's supposed to replace Times New Roman. I have to admit, I'm still a little bit. I mean, your eye gets used to things. I've gotten so used to Times New Roman that I really like Times New Roman. So, at any rate, this new font has a lot of advantages. It's being designed in particular with ClearType in mind, so it will be able to do a better job in the ClearType world than the older fonts, which are kind of there's some tricks you use to use them with ClearType, but you start losing some of the hinting because one of the tricks is just to say you have higher resolution. Okay, so Line Services 4. I already mentioned that Line Services is the standard layout component used by all Microsoft text engines. The new handler, it should be available, I think, by next summer. In combination with the new page table services, which is done by the same group, it enables the optimal line breaking algorithm that's in TeX, extended to handle, of course, any mix of the world's languages. So you can put Arabic in there and Chinese and whatever you want, and this line breaking algorithm is there. So that will improve the typography in Word just for ordinary stuff. If you turn it on, it has to be turned on, and in particular it will be very nice in technical documents. So if you combine those things, OpenType and the new font, you can end up with better typography than TeX and substantially less tweaking. Another cool thing that Eleazar and Victor and Andre are doing is they have studied the issue of breaking mathematical formulas in gory detail and have come up with some criteria as to when you can break formulas. This is actually kind of important because if you change the size of your screen, you may run into breaking formulas in a way that you wouldn't have anticipated if you're just going out into paper. So user choices are not as convenient in a web-oriented environment as they are, say, on paper. This isn't to say that users can't overrule everything. So if you don't want something to break someplace, then you can say you don't want it, or you can say, I do want it to break there. Okay, RichEdit 6.0 is a handy editing engine that we've been working on for years, and we just respond to client input. And clients want this, clients want that, and so long as the client wants it, we add it. We very seldom add anything to RichEdit that a client doesn't want. Every once in a while we sneak something in, like smart quotes and stuff like that, just to add it. But generally speaking, the clients keep us really busy. So at any rate, you can use it for plain text, rich text, single line, multi-line, Unicode or ANSI. Internally, it's all Unicode. Also, there's combo boxes and list boxes, and it's all in a single worldwide binary. It's got the things you'd need, like multi-level undo. It's got lots of different interfaces, and it acts very much like Word. And it's got rich ink support, for example, which is OneNote got us into that. It's the edit engine for OneNote. It has WYSIWYG editing of Ruby, Warichu, Tadanaka, Yoko, and Build Up Math, as you'll see. And they're just a slew of clients. So this is a partial one. A very interesting one is ePeriodicals, which is pushing the envelope. eBooks pushed the envelope for a while, and now ePeriodicals is pushing the envelope. So we're adding cool things like multi-column layout, and the ePeriodicals people are really interested in the optimal line breaking algorithm. And at some point they may be interested in math too. Okay, so some fancier features added that eBooks did. Pagination, hyphenation, kerning, subpixel clear type, text wraparound, embedded objects, added those things. Multi-level tables were a general need, partly just so you could paste HTML. HTML has relatively weak paragraph formatting, so people just constantly use the tables, which are very powerful in HTML, to do paragraph formatting, among other things. And then we added autocorrect and auto URL detection, and ePeriodicals also wanted things like drop caps. Okay, other components. RichEdit doesn't do it all by itself. It dynamically loads up whatever it needs on demand. So if you just have some simple Western text, like a file name in a file open dialog, then probably you get a very small instance size. It's single line. It doesn't have to worry about Arabic, so a lot of things aren't done. But as soon as you type in anything in Arabic or some other complex script, then it will automatically call on Uniscribe and line services. If you want tight wraparound objects, it's going to call on page table services, or if you ask for various kinds of ink support, page table services is going to be pulled in there. Something that we all call Cicero, but formally is called Windows Text Services Framework, is automatically called in if you need to use IME, so you want to type in Japanese or something like that. And then there are a slew of callbacks. We passed the buck. We're getting better at this. We've been studying line services and page table services, and what those guys do is whenever they need answers about anything, fonts, operating system information, they just do it with a callback. So they're totally portable. You can run them on Unix. You can anywhere you want. It's just C code that doesn't have any operating system dependencies or any font dependencies. It's a great idea, and it organizes your brain. You can say, okay, I've got to answer this question now. I've got to answer this question. And you answer all the questions, and you get these great results. So RichEdit isn't as clever about it as that, but we do have callbacks for access to word break, namely, well, mostly for hyphenation there. We do a lot of word break internally. Autocorrect, we say, here's the language we're dealing with. What autocorrect do you have? Clear type libraries, if you want to go out with a subpixel clear type, then you can do it that way. We also dynamically attach to OLE if there are OLE embedded objects in the documents. And then MSO is the huge library of things that Microsoft Office either wants to share among itself or make up for the lack of it in the operating system. So it's sort of like another operating system that's on top of the current operating systems. So these are all access on demand. So, okay, let's get on to what we're doing. We're combining those 8 infrastructures, putting in some powerful input methods. We're using line services instead of OLE. Line services being native text right inside the engines, so that the user interface is just an extension of the usual user interface. The font dialog works on the text inside equations, and you can search and replace across equations. Whereas if you try with the equation editor that comes as a freebie, and it's Big Brother math type, which you should use if you really are into the equation editor at all, that's inside OLE, and we don't search down inside OLE, and you can't format down through OLE, and maybe we could have fixed these things. We talked about it over the years, but somehow it never happened. So this approach lets you have all those things. So in persistence, MathML is the preferred interchange format because it's pretty well defined, and it's nicely supported now. It turns out RTF has an equation field, and that gives you some interchange capability. And the equations I'm about to show you did, in fact, we're done with the RTF equation field in Word. It has some problems. We could either extend it, but I think probably the best thing to do is just to use MathML, and we can embed MathML into RTF, do something like that. Lots of things get embedded into RTF, so why not MathML? Tech is desirable, but there are text to MathML converters, so we may just rely on them. Okay, so various kinds of input methods. You can use tech in principle. Autocorrect, I have a streamlined linear format I'll show you that works. It's like tech, but it's more like it resembles a programming language. So if you've ever programmed in a programming language, which is it's obvious, you'll know this technique. Almost. I had to extend it a little bit, but basically it's just what you'd type into Fortran or C or C# or whatever. As formulas become syntactically complete, they get built up automatically, so you can look at the result as you type along. There is the alt plus X hexadecimal input. I don't know if you know about that, but you can enter any Unicode character that way in Word or in Rich Edit. Keyboards and menus are cool and maybe more intuitive. They may not be quite as quick as a streamlined linear format. So supporting the keyboards and menus, we have a task pane, and then handwritten stuff. Okay, let's just look at something. This is a formula that was in some benchmark or other, and I typed this in using Word's equation field, not the equation editor. And in the form that I use for entry, you see this second thing here. This is the notation I used in my technical word processor, and essentially that is an input form now rather than an actual display and edited form. The standard tech version of that equation is at the bottom of this slide. It's pretty complicated. I wouldn't even want to show you what the MathML looks like. But at any rate, the tech version could look better, though, if you just use autocorrect on it. And so here's the same thing with autocorrect enabled. The guy at the bottom here is with autocorrect enabled. So already tech can look a lot better if you use Word as your tech editor, assuming you have the autocorrect turned on for math, which will happen in Word 12. But in all fairness, you could have done it with Word 97. You just have to add the autocorrect entries to take all the tech \deltas and stuff and convert them. So symbol entry is an old subject that I worked on it for years, and one of the things I learned was that if you're willing to do some QWERTYing, you can pretty quickly get to a lot of symbols. So I had 1,000 symbols on my keyboard that I could just enter by various combinations. And so you can do that if you'd like. I've sort of now come to the conclusion that autocorrect really is a better way to handle the large character set. So we'll see how this works. The hex to Unicode input method, in case you don't know about this thing, you can type a Unicode character's hexadecimal code and make any changes you want, like you mistyped it, okay, backspace, edit it any way you want. Type Alt-X and it will convert it to the Unicode character. If you type Alt-X again, it will convert it back unless it happens to be a hex character. So this is handy if you just get the missing glyph character or box and you want to know what it is. You can just do an Alt-X and see what the code is. You can resolve ambiguities by selection. And you can input the higher level. Unicode, as you probably know, has over 1 million possible character codes. So if you go beyond 16 bits worth, then you would have, instead of 4 hexadigits, you'd have 5 or 6. Okay, so formula ought to build up. I'll give you a demo of this. You enter formulas in the simple linear format, and when the expression is correct, it's built up. And you can edit them in the build-up form, but sometimes you might want to convert it back to the linear form and edit it that way. Like if you have a build-up fraction, you maybe don't want a build-up fraction. Maybe you want it in the linear form. Or maybe you want to get rid of the slash. You didn't mean a fraction at all. It was a mistake. Then to do that, you can convert it back to the linear form and change it. For special operations like integral, you type, well, what else? \int, that's what tech uses. So \int, it automatically autocorrects to 22.1b, which is Unicode for an integral sign. And then you can follow it with a subscript and superscript for limits, which ought to build up, as I'll show you. So here's the linear format math.
So sometimes you may want them near the integral and sometimes above. So do you just drag them, or what do you do?
You have the opportunity to change it, and we're thinking that you can have a style if you want for displayed equations to have it above and below, or you can overrule it on an individual basis. But I would think a style is probably the nicest way to go. You know, like the equation I showed earlier had it above and below. That's because the EQ field in Word does it that way. I don't like it that way. I like my limits to be to the right, whether they're displayed or in a paragraph. But you know, different people think differently. So one of the ideas here is to accommodate whatever you want. User is king. Anything can be done. Okay. So my linear format math is something that I developed over the years when I was doing technical word processing. And basically, a simple operand is a span of alphanumeric characters. The word span comes from snowball. Some of you know about snowball. But at any rate, it's a span of alphanumeric characters. All you do is you just take the characters, you ask Unicode, is it alphanumeric? And if Unicode comes back and says, yes, it is, that's the operand. This differs from TeX, which says that an operand is a single character or something inside curly braces. I've just found it a lot nicer to have it being a span of alphanumeric characters. Much more looks like math that way, and I don't find it confusing. For example, a numerator-denominator is just terminated by any non-alphanumeric character, including blank. So ABC/D gives you a build-up formula. Now, if you have more complicated expressions, you need to use some way to disambiguate them, and parentheses are the most common. And the technique here is, and this is the trick, the technique is the outermost parens aren't displayed when you build up. So you can see an example of that. If I have left paren A plus C, right paren /D, that will build up to A plus C over D without the parens. If you want those parens, you need to put an extra set in. So it is a markup language. I'm not denying it. This linear format is a markup language. It's just a lot simpler than TeX. Okay. So I have a couple of comparisons here of the way one TeX way to do it. Actually, that is the TeX way to do it. A plus C / over D with the curly braces. The LaTeX way, use a \frac with 2 arguments.
What if you didn't want that to be a fraction? Like, you wanted to have the slash?
If you want it to have a slash, you can, anytime you want to linearize a formula, you can linearize it. And it will display it. A neat feature about the linear format text is that typically it looks like math. Subscripts, it's stretching things a little bit, but... Okay, so speaking of which, Unicode has many numeric subscripts and superscripts, along with some operators. Well, they're there. you got to treat them. You got to do something rational with them. Typically, you'll do subscripts and superscripts, though, with markup of some kind. The input method will automatically convert it accordingly. I've been lobbying a little bit over the years for the nifty little superscripts arrow and subscript down arrow for Unicode subscript and superscript operators, but I haven't quite finished my final pitch, so they aren't in Unicode. In the interim, we can use text, underscore, and caret. And parentheses are used to handle ambiguous cases or to overrule internal precedents. Tech doesn't use precedents either, so I think precedents is kind of useful. Okay, here is Jennifer's task pane. It's got a number of ways of looking at things. You can choose your font. You can say what set of symbols you want to look at. You can get common symbols, or you can get more and more weird symbols. You could say you want arrows, you want geometric shapes, or things like that, and it will switch what's in there. Or you can just look at all of Unicode math. And a very nice feature is that the most recently used math symbols show up in a nice, get collected in a little box area for you, because you know how it is when you're writing a technical document. You tend to use some characters a lot. It's not clear which they'll be when you start out. Well, for any given person, it's clear, but not in general. It's not that clear what they're going to be. But you reuse a small set of symbols in a given document. And so then you can have single-click symbol insertion into a document. I'm sure we'll get sued by Amazon. But at any rate, in principle, you can do that. And then another cool thing is there's a little thing called My Equations where you can keep all your handy-dandy equations there. This is sort of a little bit of an idea like the tech macros, but it's different because when these guys get inserted, they can be converted to MathML unambiguously and so. So you know how it is when you, at least when I was doing laser physics, I had a lot of formulas that I just used in a pretty standard way, and I would just collect them into my equations if I had it back then. I could just paste it and then change it as need be. So that's a task pane concept. A task pane has another cool idea, and that is that we can have a browsing thing. Take your mouse and browse on those characters, and you can see the tech equivalent. So if you want to just there'll be a little tooltip that comes up so that you can know what it is that will autocorrect automatically into that character in case you don't want to, in case you want to use that method. So this is a way to discover the input methods.
How do you do Greek symbols? Like tech?
Yeah, Greek symbols are just autocorrect.
Backslash theta.
Yeah, backslash phi goes into a phi, backslash alt phi goes into the alternate phi.
Mathematical ways, escape, some character escape, and then, which I think that's a lot handier.
You like the escape approach? It's not a big deal. I tend to just, what I did for my own personal use, backslash A is an alpha, backslash B is a beta, and autocorrect just converts it for me on the fly. So, but we'll have the standard text set, and then users can always define shortcuts.
So when you do some of the autocorrect, can you put in principle all your text macros in?
Well, the autocorrect is relatively simple. It's just taking a control word.
Slash Boltzmann and get e to the minus beta h.
I don't see why not. I guess we could do something like that. We'll have to think about it though, because we may need a little bit of an indication as if like equals to MC squared, it'd be easy to autocorrect to that because that's all in plain text. If we start having fancier stuff, we might have to use some markup in there. And then then our math autocorrect procedure would have to realize that there's some markup and be sensitive to it and do the right thing with it. But yeah, you can go pretty far. You can do some pretty amazing things. You could easily enter fractions. Well, the thing is that that's already built in. But yeah, if you had you could just say, here's the name of some formula, and have it insert the linear form, and then just say build it up. So yeah, you could do that. You could do that. Okay, so handwritten equations. This is Paul Viola and other people like that in Microsoft Research, working together with people in Microsoft Research in Asia, and the idea is to come up with actual handwriting input for math equations. This would be really cool, and here's one of Jennifer's slides that you write in f of x is the integral from 0 to 2 pi of sine squared x over dx, and it will get converted. That's the idea. It's a pretty neat input method. And then, if you want, pardon? Yeah, that's true. That isn't too hard to do. But
so how do you correct errors if that happens?
In the handwriting, you can just go scribble over it and get rid of it. In the build-up form, you edit it WYSIWYG. I'll show you how to edit stuff WYSIWYG. So I'm going to give you a demo.
Could Mathematica or something like that come along later and then use that as to process that so they can do writing?
Yeah, select it, paste it into Mathematica, plot it, do...
I don't want to do all that. I just want to write the formula and have it solve this kind of stuff.
Well, you got to tell it you want Mathematica to do something with it.
Could Mathematica release a version that was like aware of all this stuff?
Yeah, right now the way to go between the two is using MathML, and so you need to, instruct Mathematica that
But
this
in
formula.
Mathematica, if they decided they wanted to, embrace this as an input method, could they?
Oh, you mean just have it as one of the input method editors? Have Mathematica?
No,
Your editor.
Oh, if they wanted to use our editor for their purposes. This I would think then they could bring up a rich edit window, and the user can type in whatever formula, and then when you close the window or whatever, it would just go into Mathematica automatically using MathML.
never talked to them about that.
I haven't actually talked to much of anybody outside Microsoft about this stuff. I gave an early demo to the equation editor people, Design Science, a couple of years ago at a MathML meeting. But,
Why not first go into Excel?
yeah. Excel is just an
Right, you
excellent
might
idea.
have a table and you sort of grab your formula and then you put X and down you put in your table X and it displays automatically the value and stuff.
Well, Excel uses rich edit a lot already, so the infrastructure is available there. So they could just simply say, have an option, bring up this cell, bring up a rich edit instance for what's in that cell, and it would be exported to rich edit. And then rich edit would let you write the formula and build up form, edit it, WYSIWYG style.
So you emailed me a letter which had sort of this formula in it, and I just want to open my Excel and
paste it.
and paste it and then use it.
Yeah. Well, that's the same way. You can use it for input, editing, or output, or whatever. So if we can make this connection, it has a little lower priority in Office 12, even though I think it's incredibly cool. But PowerPoint and Word and OneNote those are our three principal targets, and we don't want to miss on those. But yeah, Excel is clear. So I'll give you a demo that shows a bunch of these things. Rich edit, auto formula build up, pasting into Word, saving as X to HTML with embedded MathML, displaying in IE with Math Player, and I can even show you something with OneNote. The formula driver that I'm using for line services is actually the fifth time I've written such a thing. The first time was back in 1970, and David Hansen knows about that one because he worked with it and extended it back in the old days, back in the early 70s. And then I did a Snowball 4 version, which was really fun because Snowball 4 is so powerful. You could do wild things. And then the next version was a daisy wheel controller. I fitted it in to build up equations into 16K of Z80 code, went into a controller. And then I had this PS Technical Word Processor, and you'll see some stuff of that because I used it as input to formulas, to C++ compilers. And then finally this line services driver. Okay, so let's go and I want to just go check out a couple of things. Let's go over here to this guy. Now, this is a rich edit test program running rich edit, and you see a bunch of stuff here. I already wrote this in. So if I can go select some stuff, I could copy it. I can come down here like this, and I can paste it, and then I can come down here, and I can paste it some more. I can paste this down here. And so all of this stuff is just, this is actually a debugged version, but it's absolutely instantaneous. I mean, it's just, there's no hesitation at all. You can WYSIWYG edit this stuff as much as you want. If you bring up Word, I can go back over here and I can select everything and go over to Word and paste it into Word. Word's thinking. And there it is. Oh, there's an error on that one. Oh, yeah. Yeah, that's right. I forgot. Word's equations can only be embedded 9 levels deep, maximum 9 levels deep. Rich edit can handle 300 levels deep. I mean, if you want to make a continued fraction that goes 300 levels, I mean, actually, there isn't a limit. There's no, there is a limit. It's 256. I use a byte to store the nesting level. Okay, so yeah, Word is upset about this guy here. Let's go over and let's go say, let's do some undos. So now I'll say Control A, copy that, and go over here and I'll do an undo and paste that one, and that one works okay. So you might say, well, how do you communicate with Word? Well, let's go over here and say toggle field codes. That's called the equation field. It's a linear format, and Word's been able to do this since the mid-'80s. Okay, so that's an example of what Word can do. Yeah.
How do you type in your linear format to this thing so that it shows up as math?
Okay, let's try this. Let's say I say A equals, say, B slash D plus E slash F plus G, make it a subscript. And then let's do another one like that, and then go like this. So that's how you do it. You type it in, and as you're typing, it automatically converts it. If I go over here and say int for an integral, and I want to put a subscript A and a superscript B, then I can do that. It builds it up. X, F of X, say X minus Q.
Now, is this happening because you have your own autocorrect things that you told it about, or does this happen for everyone?
This is going to happen for everybody.
Okay.
You probably don't have Word 12 because it hasn't been created. That is a problem. That is a problem. Yeah.
You have to go into math mode to do this?
Pardon?
Is there a math mode you have to go into?
Yeah. This is something that we've been talking about a lot. You know, heuristics are great, but heuristics are not infallible. We can spot math pretty well, but ultimately it's very nice to have something that says this is a math zone. And inside a math zone, the typography is different. The spacing around operators is carefully controlled. You can overrule it, but if you don't, you'll get really nice quality typography. So I have a math zone turned on right here. If you look up at the top up there, you'll see the rightmost button is a Q. That means that it's in a math zone right now. Yeah.
And then if you're in the math zone, you get the better line breaking for just regular text as well?
No, you get math line breaking.
That's it.
It better be math.
No,
Oh, you mean optimal line breaking?
yeah, the way text.
Oh, that's independent. Yeah, that's independent of whether you're in a math zone or not.
Okay.
Yeah. No, the paragraphs would be broken using that if you turn that on.
Okay, great.
Yeah.
So if you give this document to somebody who has an old version of Word, what do they see?
Well, That's what you see, because this is an old version of Word. So you are interoperable to that level, but this is not WYSIWYG editable. You've got to go to edit this thing. You're going to have to go to the equation field. And just how far we can push this, I don't know. We have to think a little bit about.
As long as I don't just see garbage or something.
Well, now one of the cool things that you can do is if you take this stuff and export it. Like let's take this thing here, and I'll just let's go over. Wait a minute. Control F9. Ah, I managed to break my linearizer. I wonder why that broke the linearizer. Yeah, this. But basically, you can convert it back to the linear form, and you can export it that way. So at least you can see that.
So do you have to save that, or can you just say save as Word file?
Yeah, I mean, we can dump it.
I mean, why can't you save it? What I would wish probably if I say save as Word 9, I would want to see actually the formulas in it. So maybe the other person can't really edit it.
Right. Yeah.
Right.
Might
So-
be further to the linear.
Yeah, and then there's two possibilities. It could go out in the form for the equation editor, or it could go out in the form of the EQ field. And maybe we should just pursue the EQ field just for that purpose. It's an interesting idea. Because the EQ field is actually fairly powerful. So
How do you
it's been in, the EQ field's been in since 95, I think, Word 2 or something like that. Word 3. Charles Shimoni can tell you more exactly when it was added. But yeah.
When you print it, how do you ensure this keeps it in the same format while printing?
With printing? Well, if I had a printer, I could print this. It would look like that.
Right. What's the technology?
Which technology?
What is the technology to ensure it prints like that?
You know, it's just Windows. It shows up on the screen. It shows up on the printer. You know, there's no problem. I can easily go print this thing. I just go to File and say Print, and it would go right out. You can see that on the printer. That's a nice feature. One of the things that I did first, just getting this going, was to work on Ruby. And Ruby, I can nest Ruby, you see. I can go up here and put some Ruby in there, really mess it up. And you might say, well, you don't need that. But actually, to do the HTML spec for Ruby, you do need nesting of Ruby 2 levels deep, or something equivalent, because you can have Ruby above, Ruby below, and you can have a bunch of Rubies. And if this were to talk about Ruby, I'd show you more about that. But the reason I got into doing recursive editing of Ruby is because, hey, Ruby's like a fraction. So I figured if I could edit Ruby recursive, WYSIWYG style. Okay, Ruby is, in this particular case, is, let's see what I've got here. Blow it up a little bit. In the upper left-hand corner there, the big characters, the sun character, the root character, and the language character stands for Japanese. And right above it is the corresponding hiragana that says how you pronounce that in Nihongo. So Ruby is a pronunciation guide. It says how to pronounce things. But it can be used for other things, too. It can be just a little comment on something, too. And in the HTML spec for Ruby, they give you a date that's sort of annotated this way, and it says what the date means. Sort of very cool. Okay, another example which I think is kind of intriguing is this one. OneNote is a neat program that some of you may know about, and I already typed in a lot of stuff into OneNote, plus Q and stuff like that. OneNote uses Rich Edit as its editor and display module. So since Rich Edit has this stuff in it, OneNote gets it for free. And we're going to do the same thing with PowerPoint. The deal with PowerPoint is that PowerPoint's editor and display engine is going to be RichEdit 6.0 for the next version of PowerPoint, PowerPoint 12. So PowerPoint automatically will have all the same stuff, and you can paste it from Word into PowerPoint and vice versa. This will make you a lot more interoperable when you have to do a presentation like this one. So let's get back to this guy for a little bit. We could say, where else do you want to use this stuff? And Publisher came up in the discussions. And in fact, OfficeArt, which is going to use RichEdit as its editing engine, and appropriately modified. There's work to do, clearly. But OfficeArt is probably going to end up rendering Publisher also, but it won't be in Publisher 12. It's just, shipping is a feature. So we'll do Publisher 13. Avalon Text is an obvious place to go stick it, but Avalon has a pretty full plate right now, so the chances of getting it into Avalon this iteration aren't that great.
Murray?
Yeah.
Any estimate on how big a task that is?
Put it into Avalon?
To put it into Avalon?
Well, Avalon is using line services also.
Right.
And so the main problem of getting it into the text engine is the user interface level. And being able to display the equations is one thing, and being able to edit them is another whole project. Being able to select equations and do things with them is another whole project. So it takes time. I mean, I think it would really distract those guys if we push too hard on that level at this point. They've got enough they have to deliver. So one of my favorite topics is where else would you want to use this, and namely the answer is programming languages. It seems to me that it's too bad in many ways that the programming languages haven't looked more like math over the years. In many ways, programming languages haven't gone that far beyond what Fortran did. And Fortran certainly made great steps in getting math into computers in the first place. Java and C#, Java actually deserves the credit for this, accepted Unicode variable names. That was already a huge advance from the point of view of making things look like mathematics. And C++ with a preprocessor and operator overloading allows you to do other cool things. So I'll give you a little demo of what I did back in the 80s using C++ with my technical word processor for entering programs in laser physics. A key is that compilers need to use Unicode characters. And they ought to allow the math alphanumerics, because it's really cool to use an italic I as an index on a for loop rather than using some cruddy old I or some bizarre name that we typically use as our indices on. And if you're doing something that's mathematical and an italic I is what shows up in print, you might as well have it in your program. So there's no reason you couldn't do that. You use the linear encoding of mathematical expressions, but it would be nice to be able to run it through a RichEdit control so you can see it build up. So anyhow, I'll show you an example of a program. This is a program from inhomogeneously broad and multi-wave mixing, which is a nonlinear wave mixing that I used to work in. And sort of the traditional C notation for this would have names like gamma p, which stands for gamma prime, and gamma times square root and stuff. So if we autocorrect that thing, we get this. And that's typically the way I work with my equations back when I was working in the physics area for the last 6 or 7 years. And all I had to do is tell my editor that build it up, and I'd see it like that. And this actually is very close to what appears in print. And I was able to just code up relatively, this has got a lot of complex variables and stuff, I was able to code up formulas and graph them almost immediately. Because I just take it out of my documents, I did all the algebra in this notation in my documents, so I developed the formulas, they'd already be in the documents, and I would just paste it into the C++ code. And I had to do a little bit of trickery, so I used underscore tech names, like underscore ALPHA as an alpha, and And the C compiler was C++ compiler was very happy with that. The only reason I was using C++ actually was to get complex numbers at that point. I use it for other things now.
How'd you miss FABs and how?
FABs.
Absolute value.
Yeah, I mean, why didn't I use vertical bars, you mean?
Or POW.
And POW. Yeah, right. Yeah, I should have overloaded those things, I suppose. Yeah, I could go only so far. I think I tried to use the caret for power, but I had some problems. C++ is pretty good, but you can't really define new operators, and you're limited. Like you only have one multiply operation, and so you can think of in physics, you can think of at least 5 different kinds of multiply that are common. Cross product, dot product, things like that, matrix products. So you're somewhat limited with C++ that way. If we could have more operators, some languages allow you to define new operators.
You got like beta squared now.
Yeah, right. Well, that's a name actually, beta squared. It's a beta character followed by a superscript 2, and I did a sort of a no-no there. I defined beta squared inside there, and I got beta by taking the square root of it. But I needed beta squared down below, and I figured why not get the full accuracy while I was at it. That's all complex. These epsilons that you see are complex frequencies. So they have a damping factor as well as an oscillatory factor. So at any rate, here's some useful references. Unicode standard itself is all on the web, but you can buy it, and it's a good workout to carry it around. It's huge. And then Barbara Beaton, Asmus Freitag, and I wrote a technical report about Unicode support for mathematics, and that's out on the website. And of course, Donald Knuth's tech book is one of the classics in the whole field, as is Leslie Lamport's LaTeX, Leslie being a Microsoft researcher. If you want many, many, many more books on mathematical typography, I refer you to Eliezer Cohen, who has them all. And then MathML 2.0 is documented. I give you the place where you can find that. So here are the conclusions. These 8 infrastructures allow us to do math display and editing better than ever before. High-quality line services math handler enables us to actually exceed the quality of tech. The original goal was to match tech's quality. That's before Eliezer decided it was going to be better than tech. So, streamlined input methods facilitate the math entry, make it a lot easier to work with. And we want to stick it in all these different places and maybe future compilers. So thank you very much for your attention. If you have any more questions, I know we've had a lot, but yeah.
Is that a point where we can play with it ourselves, or are you still going to keep it?
Let's see. You have REITP. In principle, you ought to be able to do it in WordPad, but the trouble is that we changed the name of the DLL in WordPad, so it's a little bit hard. So we can just give you a new DLL. If you want to fiddle with it, I suppose you can. Yeah. Send me an email.
You mentioned there was a tech program on was better than tech, but the talk was restricted itself to one platform.
Oh, I didn't want to say it was better than tech. But I see what your point is. Yeah, would this run on the Macintosh or on Linux or? I don't know. Good question.
Okay, so you probably want somebody else you converted into HTML and then read it.
Oh yeah, the documents are portable. We'll export the formulas as MathML. We'll do an extension for RTF. One thing I didn't show you is that I can take that stuff and dump it into XHTML and CSS and display it with IE using the math player from Design Science to handle the MathML namespaces. But our thought is what we want to do is we'll make a rich edit control that handles behaviors for IE. And then we can get the same display of formulas in IE that we have in Word.
But still, I probably can't write a paper with a quantum level station.
Yeah, let's see. If you want the high quality, probably the MathML can give you very legitimate quality for the math part, but it doesn't. XHTML is relatively low quality typography in general. So if you really want text quality, I guess we should have a tech output. It's an interesting point in favor of supporting a tech converter, just because how would you be cross-platform?
My thing is to go in Word, go to xxx.mlanow.gov, pick up a document that looks great on Word, fiddle with it, and submit it, and you're happy. And is this within the realm of reason?
Well, I think the best thing for publishers to do is to use Word to publish mathematical documents to solve all their problems. Really easy.
When I use tech, I like two things. I like the typesetting, which you've talked quite a bit about, but I also like and use probably even much more the facility of the macros, which allow me to type in various things and then later decide what it's going to look like or change what it's going to look like. It seemed like from what you explained, the only way that you have to change things is by search and replace. And you said you can search for italics I instead of other I's. But I didn't see anything else that would make me quit using LaTeX and use this instead. Do you have such features? Or, I mean, how do you even work that?
How do you...
I mean, how do you... Someone writes a matrix, for example, and now you want to change the brackets around the matrix.
For changes like that, the thought is, and we haven't actually finished the spec on this, the right mouse click means a lot in the Windows environment. And so if you right mouse click on your, let's say you have regular parens, you want to change them to brackets, you right mouse click on it and a little menu comes up and it lets you choose, make your choice.
But I want to do it not just for all the other ones. Right, I want
oh, well, the way you input a matrix is you're putting the characters in to begin with. I mean, if you want left paren, you put a left paren in, and then you put the matrix in, and you put a right paren.
So now I have a paper with 100 matrices, and just those that...
and then you want to uniformly change all matrices.
Or maybe most of them, the ones that are used in certain contexts. Now I want to change the bracket of those. Is there additional information that lets me say this?
It'd be easier to change them all rather than... Well, no, but you could go one by one with a search replace.
How does tech help you?
I write two different macros. One called A matrix and the other one called B matrix.
You keep in mind, right? You just say OP1 and OP2, and then later when you sort of, before printing out, you define what OP1 means and OP2 means.
Yeah, the macros definitely have their utility. And I explained how they were a bane and a blessing. They're really good for when you just want to have batch output of your stuff. For interchange, they're really bad. So, you win and you lose with the macros. And I think it's better to have a form that is fully evaluated at all times, and then powerful search and replace. So, we could probably do some things that are along the lines you're saying, but it wouldn't be quite as convenient as just saying,
Wouldn't it be possible to have macros and a function that expands macros for export and interchange?
Yeah, I would think that's a good thing to do with tech, for sure, if you wanted to try to make it more interoperable.
But for this also, so that I can have macros in this, and then expand them so that it can be interchanged and given to somebody else.
You could probably do that, do it with styles or something like that.
Can you put some, I mean, maybe when you have this parenthesis, can I put in something which never will show up in the displayed form? Because I could just say, okay, this parenthesis, I just give it an additional little name which you never see, but then when I do search replace, I add this little name to it. That's it. So that could effectively work like a macro.
Or maybe you could use the word styles that exist today.
Styles are one cool idea. Another is just embedded fields. So you could have an embedded field, which you just change the meaning of the embedded field. Eliezer, you have a...
I'm Eliezer Corner. My team and Murray's team are working to make this possible. May I use this audience for a quick survey? In Word there is an equation editor which comes, in Word there are two things. There is the equation field and there is the equation editor. May I ask who is using the equation editor?
Is using or has used?
Excuse me?
Has used.
Okay.
Has used?
How many people use tape to do their equations?
Use what?
In Word or just normal? I mean,
In the past, I want to see what are the, how many people who showed up hands about Word's equation editor have been happy versus unhappy. So how many are happy, have been happy? How many have been unhappy? Okay, can I have a few reasons why you have been unhappy? We don't want to repeat the same mistake. So
Have you used math type? And it's better than the equation editor, right?
Not in some ways. Not in some ways. You give your document to somebody else, some of the symbols get converted to gibberish. They can't read it.
Say I'm doing a PowerPoint presentation, so I want the equations to be bigger. Then I try to edit a Word document. It forces the same size. All of a sudden, I get giant equations. It's probably a bug in Word.
Okay.
It is probably a registry setting or something like that.
okay, thank you very much. Other
The
voices?
simple thing which I think you're addressing is the equation editor is incredibly cumbersome and painful to use, and after all that, the results look awful.
Very good statement. What do you mean? Can you elaborate with one or two sentences what you mean with it's difficult to use, and one or two sentences the results are awful?
Lots of clicking through menus
Okay.
to find the things I want, just very simple things that are natural, could be done simply linearly. You have to go deep into menus to find out, or remember elaborate control sequences.
Very good. What do you mean with the results look awful?
Just the kerning is often very bad. It doesn't look like well formatted mathematical text. It looks ad hoc.
Okay, thank you very much. Other voices?
Word chokes when there are like hundreds of equations and just chokes.
Yeah, for me, a lot of the problem is it's just very buggy. I see things seem to just get converted into bitmaps suddenly, or a menu. You try to bring up a menu and it won't bring it up, or you try to change a font and it won't change it. It just kind of refuses to do things sometimes.
My experience is very limited, but the one time I tried to make use of it, I realized that if in the equation editor, if you make a mistake and then you go on, it seems like you have to undo everything back to where your mistake was. The one that sticks in my mind is I chose the wrong kind of open parenthesis, typed a whole bunch more stuff. I had to redo all that back up to where I put in the wrong parenthesis.
Mine was I need to touch type these equations.
What do you mean?
I need not to use the mouse to get
This is the same here. That means it seems that the interactive editing of formulas is a little bit problematic. You like the command line type input.
Cross-referencing for the equations are just more quite often doesn't do what I expected.
Okay.
The lack of search capabilities would be bad.
Yeah. Okay, I thank you very much.
I just put this up just so you can see that you can export the thing in XHTML and CSS and display it. The typography isn't that great, but this is using the behavior facility in Internet Explorer, and the behavior in question is from the equation editor people, Design Science. They're a math player. So we hope to do something like that. Yeah.
So what about equation numbering? Do you handle that, or is that handled by Word somehow?
That's actually a marriage of two things. The The line services handler has support for equation numbering, but it doesn't automatically increment the numbers. The callback says what the number is going to be, and Eliezer can give you thorough details on that. But that means that Word has to have equation numbers supported, and that is in the plan. Yeah, you need equation numbers.
So can you do some more fancy things like indexing and references? And I mean, if you write a book in LaTeX, you do all this stuff which sort of goes automatically.
BibTac and all those cool
Word
things.
supports references.
So reference is fine, but also sort of index, right, and stuff, so you can...
Word actually has indexes. I mean, Word is a very rich environment when it comes to documents. It's just been sort of bad with equations. But, so hopefully by adding this, we're studying LaTeX. I mean,
So serial numbers and stuff like that, you would have no problems.
which kind of numbers?
Well, you don't only want to number equations, but you number theorems and lemmas and definitions, and maybe you want the lemmas numbered starting again in a chapter and stuff like that. So all that you think you will be able to do. I mean, LaTeX does all this very nicely.
Word can do
We
a lot
ought to-
already.
Word can do extraordinary numbering, but whether it can do everything as well as, I mean, it can do a lot that LaTeX can't do, but it's not clear it can do everything that LaTeX can do either, so we should probably compare them to see.
So, and then in the final analysis, the documents aren't going to look really crummy anymore when you print them. I mean, that's probably the biggest problem I have with Word and equations now, is that documents look crummy when you print them.
They're going to look better than LaTeX.
Okay.
Absolutely.
That's
Yeah.
it's worth extra effort, It's just, you finally get all this done and get through it all, and then it just looks...
Yeah, it looks terrible. But we do have this problem as to well, PDF, I guess, we're just outputting PDF. If worst comes to worst, we want to be interoperable. That's what most people do at tech anyhow. Here's a PDF file of my... So we can do that and be cross-platform to whoever was asking about cross-platform.
compile the thing and then view it in a separate program.
Yeah.
I would love to not do that.
Yeah, well, this is all WYSIWYG, so just...
So when is Office 12 coming out?
That's a hard question. It depends on Longhorn. It's supposed to coincide with Longhorn. So.
This is not specifically math related, but did I hear you say that Office Word 12 specifically is going to have a better line and paragraph breaking?
Yeah, it'll have an option to give you the optimal line breaking algorithm that Tech has, and actually it's been generalized to handle all the languages of the world. Well, all the commercial languages of the world, all the languages that run on Windows. So you can mix and match, and you can have tight wrap around objects and do a lot of things that you can't do in Tech. So it is. If I have to summarize the whole thing in just a sentence, it is outrageously exciting.